In this session, we will give the outline of deep learning and have a brief introduction of artificial neural network, multiplayer perception, backpropagation algorithm to train multiplayer architectures, and several classical deep models. Learning plays a bigger role in the design circle with deep learning. Feature learning becomes a part of the end-to-end learning system and makes the key difference. Pre-processing becomes optional means that several pattern recognition steps can be merged into one end-to-end learning system. Design network and train network become very important work in deep learning technology. Sometimes, we underestimated the importance of data collection and evaluation. In real applications, we should know that not all the data sets and prediction tasks are suitable for learning features with deep models. An artificial neural network, ANN, learning algorithm, usually called neural network, NN, inspired by the structure and functional aspects of biological neural networks. An ANN is based on a collection or connected units called artificial neurons. Analogous to axons in the biological brain, each connection synapses between neurons can transmit a signal to another neuron. Typically, neurons are organized in layers. Different layers may perform different kinds of transformation on their input. Signals travel from the first input to the last output layer, possibly after traversing the layers multiple times. As of 2017, neural networks typically have a few thousand to a few million units and millions of connections. The original goal of the neural network approach was to solve problems in the same way that a human brain would. The history of ANN has gone through several rises and falls. In 1943, McCulloch and Pease created a computational model for neural networks based on mathematics and algorithms called threshold logic, which marked the birth of neural network. In 1958, Respelent created a perceptron algorithm, which is just the simple one-layer network, and put forward NN research into the first rise. In 1986, Hinton and his co-workers invented a backpropagation algorithm and made a multiple-layer perceptron into realization. NN research raised for the second time. In the year 2006, Hinton invented DBN, Deep Belief Network, and found that the deep network has powerful feature extraction capacities and can be trained layer by layer to achieve deep training. In 2012, CNN, Convolutional Neural Network, was successfully used in ImageNet competition and promoted the third rise of NN research. Up to now, different kinds of deep neural networks have been invented and widely used in many research areas. The simple single neural perceptron is just a one-layer neural network, which is based on the McCulloch-Pease neuron. It consists of a weight, a Bayes and a summation function. In the standard perceptron, the net is passed to the activation transfer function, and the function's output is used for adjusting the weights. Perception is the first ANN, which has the ability of learning and becomes a building block for deep neural networks. The problem like XOR cannot be solved by a perception, but is solvable with a two-layer perception. The two-layer ANN has good performance in nonlinear classification. We could view an ANN as a connected, directed graph, which defines its architecture with two types: feed-forward nets with loop-free graph, and recurrent nets with loops. The figure shows a general structure of feed-forward net with two layers. Since the input layer consists of source nodes, it is typically not counted when we talk about the number of layers in a feed-forward net. There are three components characterize a neural net: architecture, which is the connection pattern between the different layers of neurons; activation function, which converts a neuron's weighted input to its output activation; and learning rules or learning algorithm to get the optimal width of the connections. Multi-layer perception, MLP, is just a multi-layer neural network, also including two layers net. Consider a network with L layers. The input to each neuron can be expressed as a summation of the outputs from the last layer. The output of each neuron is the result of the neuron's weighted input by activation function. MLP is more powerful than single-layer nets, which can learn to approximate any function if given sufficient layers and neurons. But it has computation problem if there are more than one layer. Later, backpropagation BP algorithm was invented to solve the computation problem of NN. Backpropagation BP is a common method of training a neural net and is a critical part of most artificial neural networks. The learning procedure in NN is to derive BP algorithm by cost minimization, where gradient descent. Due to the complex structure of neural network, the calculation of gradient is expensive. Thus, BP algorithm is used to optimize the network parameters layer by layer. It does not calculate the gradients of all parameters at once, but from back to front, first calculates output layer gradient, then the middle layer, and finally the input layer. BP algorithm is composed of forward propagation process and back propagation process. In the forward operation, the input information passes through the input layer and the hidden layers and transmitted to the output layer. Then, the initial system output is compared to the desired output. If the target values cannot be obtained in the output layer, the process switches to back arrow propagation and obtain the gradient of the object function to the model parameters, that is the weights, layer by layer. The system is adjusted until the difference between the output and input is minimized. Shallow nets involve one hidden layer of feature detectors, followed by an output layer. For example, MLP with one hidden layer, RBF, radial Bayes function, and SVM, spot vector machine. Deep nets use more than one hidden layer. For example, convolutional nets to overcome the overfitting problem. We train a deep net by dividing training into two phases. Use unsupervised generative pre-training to initialize the deep net. Then use discriminative fine-tuning to finalize the net. DNN have been successfully applied to a large number of tasks. Classical deep models include convolutional neural network CNN, deep belief net DBN, autoencoder, recurrent neural networks RNN in 1990, and long short-term memory LSTM, and so on. The key idea of convolutional neural network CNN is to replace layer-wise matrix multiplication in MLP with convolution. Three kinds of layers are used to build a CNN architecture: convolutional layer, pooling layer, and fully connected layer, like in conventional MLP. In CNN, there are three kinds of operations, as shown in the figure. The first step uses convolution operation to convolve the learned filters with the image-getting filter maps. The second step uses pooling operation, especially max pooling, to compress a certain area of the previous layer's data into a value. The activation function often uses rectified linear unit, ReLU. This architecture allows CNN to take advantage of the 2D structure of input data. CNN are suitable for processing visual and other two-dimensional data. Recurrent neural network RNN are popular models that have shown great promise in many NLP, natural language processing tasks. For example, if you want to predict the word in a sentence, you better know which words came before. RNN are called recurrent because they perform the task for every element of a sequence, with the output being dependent on the previous computation. Another way to think about RNN is that they have a memory which takes the previous outputs or hidden states as inputs. The idea of RNN is to make use of sequential information. The nodes between hidden layers are no longer unconnected but connected, and the input of the hidden layer includes not only the output of the input layer, but also the output of the previous hidden layer. Long short-term memory LSTM networks are RNNs that avoid the vanishing gradients problem. An LSTM unit cell includes memory to maintain information for long periods of time. A set of gates is used to control when information enters the memory, when it is output, and when it is forgotten. This architecture lets the unit learn longer-term dependencies. LSTM combines with CNN became a mainstream framework in the field of deep learning for speech processing. That's all for this session. See you next session.